All right, so I need to give you guys a rule that your book calls the quotient rule, which is just like, hey, what if we divide and there are exponents kicking around? Like, how do I deal with that? So here's the idea. Say I've got a to some power, and I'm dividing that by a to some other power. Kind of off to the side here, I'm going to just assume, oops, I have no idea how to spell assume, that the number on top's bigger than the number on the bottom. Okay? Maybe equal. What the heck? So what I'm going to do is I'm going to think about what this means. This means that there's a bunch of a's multiplied together on the top, right? So there's specifically n of these. And then on the bottom, there's some a's multiplied together, specifically m of these, right? But I'm just going to go through and I'm going to say, hey, look, this business right here, that's an a over an a, right? So that's 1. So do I really need to write multiplication by 1? No, not really. So I can replace this with a 1 and then disregard it. I'm going to do the same thing here, right? Some of you guys will call this canceling, right? So I'm going to go through, I'm going to cancel. When I run out, right, since n was bigger than m, I'm going to run out at some point. And then how many a's are going to be left on the top? Now, I hope this is like a grade school takeaway question, right? This is like, there were n a's on the top, and then somebody came along and took m of them away. So now how many are there? I think there should be n minus m a's, and they're left on the top, right? So really you might think over 1 here if you really wanted to. Cool. So this gives you a rule for exponents, which is when you're dividing, you can subtract the bottom number from the top number. And all of that is like canceling some stuff. Cool? For example, what if I had 5 cubed divided by 5 squared? Let's see, I think one way I could do this is I could multiply 5 times itself 3 times, and then multiply 2 by itself, or 5 by itself twice. So I could do, okay, that's 5 times 5 times 5. Then I'm going to divide by 5 times 5, right? Or I could just notice, hey, that's a 1. This is a 1, right? So I'm just onesying, right? And I get, let's see, after all that junk's gone, I've got a 5 really over 1, right? And I could think to myself, oh, hey, I could have done that a bit faster by just noticing there's 3 on the top, 2 on the bottom for exponents, so I could take the top exponent, 3, subtract the bottom exponent, get 1. Oh, hey, yeah, that's 5. Cool? Check. Okay, one quick little caveat. If you had 5 to the third divided by 5 to the third, you could use this rule, right? To say, okay, that's 5 to the 3 minus 3. That's 5 to the 0. And then this is a little confusing because I don't know what to do with this thing, right? Okay, but this has to be something, and it has to be this. But this is just a number over itself, right? So this thing has to be 1. So this is another rule that you can write down. That any number a to the 0 power is 1. Okay? With one small exception here, which is except 0 to the 0 is undefined. Okay? So don't put 0 in for this bottom thing. That doesn't make any sense for a reason that we'll talk about later.